the viral infection or those kind of things, that's gonna cause the animal lost appetite. And when they lost appetite, gonna have the emaciation, and then can get the content or the energy from the food. We use the pharmacological management to stimulate the appetite. And for the appetite or the eating behavior or stop eating behavior, they control by the hypothalamus center. And the center, they have two types of center together. First is the hunger center. It's a green dot right here. They have green dot, both of them. The location is the lateral hypothalamus. You don't need to memorize for the location about this. You need to know about the physiology about that. And the second is the satiety center. Satiety just means stop eating. And how it's working. The once the animal feeling hungry, they're gonna start eating. And when they start eating, the blood sugar level in the system is gonna be increased, and that's gonna send the signal to the satiety center. And when the satiety center is stimulated, the animal gonna stop eating. And once stop eating, the blood sugar gonna be dropped down. And once drop down, gonna stimulate or send the signal to the hunger center again, and gonna become the eating, gonna be this cycle. But the blood sugar level is not only thing to send the signal of both these two centers. It can be any hormones, neuropeptide, cytokine, or neurotransmitter. That I have the list in here, and the species dependent too. Because some species, they have more, that neuropeptide can increase the satiety center more than that. But this list is commonly they found in almost all the species, like the one that increase food intake or they stimulate for the appetite center is the norepinephrine, dopamine, GABA, ghrelin. Ghrelin is and we're going to talk about that, and pancreatine. And the signal that decrease the food intake or suppress the appetite is the serotonin, cholecystokinin, or calcitonin. Okay. Do you have questions for this slide? Okay. And the agent that appetite stimulant we use in the clinic, there are two types together. First is the non-specific stimulant. Non-specific, I have three types. First is non-specific stimulant. And that includes glucocorticoid and vitamin B. Glucocorticoid, we don't know exactly what the mechanism of action that increase the appetite. But we know from the dog or the animal on the glucocorticoid, they just start eating non-stop, right? They just start eating like they have like increase the intake both of the water and both of the food. And vitamin B, they have less efficacy once you compare with the glucocorticoid, but they also have the effect from that. So vitamin B, they have the theory about like maybe they have the signal included with the blood sugar in the system B. And the second type is the direct stimulant appetite center, which is right here, which is a diazepam. Diazepam, they stimulate at the hunger center. And that hunger center, they stimulate by the GABA receptor. But we didn't use a lot in cats because they can cause a hepatotoxicity in cat. And for this, diazepam is not working or is not effective in dogs. So it's not commonly used to increase the stimulant, but they have the effect to increase its appetite. And the other direct stimulant appetite is a captopril. Captopril we're going to talk about next slide. And the last type of the appetite stimulant is the cyproheptadine, which is right here. This one is indirect because it's not stimulate directly to the hunger center, but is antagonize effect to the satiety center. So by via the serotonin receptor. So it's commonly used in cats with the eating disorder or have the chronic condition in cats. And the last one we're going to discuss is a captopril. Captopril is a new drug and is the FDA approved to use in the small animal, only in dogs. Basically the captopril, the structure is similar to the ghrelin, or they have the mimic ghrelin effect. So they're gonna stimulate directly to the hunger center. Or they call the ghrelin hormone as a hunger hormone that by the receptor, the same with the ghrelin receptor in hypothalamus to trigger the appetite, and that causes the behavior of eating. Be careful because this one is a new drug. We don't have the good information like post-marketing surveillance or the clinical trial about the toxicity, but you have to be careful. Once you use, you have to monitor closely about the hepatic function and the renal function. And the adverse effect, because the drug is just, can cause to the blood barrier, can cause the extra, cause the central nervous system, that can be include vomiting or the hypersalivation, polydipsia. And some information, they say they have the adverse effect of the diarrhea too. So you have to be careful about the new drugs using. Any question? Oh, yes.
I might have missed this, but you said it mimics ghrelin. What?
Ghrelin is a hormone. It's a hormone that stimulates directly to the hunger center. Right here, the green dot, yeah. So it's like the ghrelin hormone analog. That the name of the drug is the captopril. It's launched 2016, that's me last year. It's just launched 1 year, yeah. It's totally brand new, yeah. And only approved to use in dogs, not in cats, yeah. And we're gonna go ahead to do the, yes, sir.
So I didn't see where you mentioned mirtazapine, and that's when we use, I know it's a TCA, but we use it all, I've seen it like in every hospital we work in.
Okay. To use it increase the stimulant?
As an appetite stimulant.
Okay. Is used, the mechanism of action is similar to the diazepam because they have the GABA effect. It can use to increase the appetite, but for anything to relate with the GABA receptor, I would not recommend that because it can have the adverse effect for that. Yes.
So then why is it used so often in clinics?
I don't know. Yeah, honestly, I don't know. Like a glucocorticoid can cause a lot of adverse effect, but before they use that, they use a lot of glucocorticoid to increase the stimulant too. Yeah. Okay. Yes.
Do you know if it's cheaper? Why vets choose to use that more? Or?
I don't know. They use a lot in dogs or they use a lot in cats. Both. Because the cat, they can use the cyproheptadine is work very well. And if they use in dog, I think the cyproheptadine is not the same effective to use in cat. That's why they use a lot in dog. And I don't know, honestly, yeah, I have to look at that. Yeah. We're gonna go about the vomiting or emetics problem. So the drug we're gonna be emetic agent and anti-emetics. And we have to know that the emetic is a complex control system because it's controlled through the emetic center in the brain. And it's a species dependent too. We know dogs and cats is very well developed of the vomiting center or humans. But the rodents or ruminant not well developed. You can find less common when you compare to dogs and cats, but the horses or rabbits is not well developed at all for the emetics. But once you find the vomiting in horses, they said that can tell you it's the last stage of their life. That means you can not do anything from that. Yeah. Okay, for the emetic, it's not good in the clinic, but the system or the process is, you have to think about, it's good because it's just like to protect the body, to get the toxin from the body, right? And the way they protect it, they have to come up some system for that. Think about like once you ingest a toxin, they're gonna absorb to the systemic by blood. And that toxin can be xenobiotics, cytotoxic drug, or the urea, or anything that become the toxic in the body. And that toxin, is a chemical toxin substance gonna send the signal to the chemoreceptor trigger zone. The chemoreceptor trigger zone is like a chemosensor that can send to is a toxin or non-toxin. And the chemoreceptor trigger zone, it should not protected by the blood-brain barrier, right? Because it can be to have like a sense of the toxin in the blood, in the systemic. And there are the several types of the receptor on the chemoreceptor trigger zone. There can be dopamine, and 5-HT3 is a serotonin type 3, muscarinic receptor, cannabinoid receptor. And once the chemoreceptor trigger zone, they're stimulated, they're gonna send the signal to the emetic center. The emetic center, they send the signal. Right now we know they have the 4 types of receptor together: muscarinic, histamine, serotonin, and neurokinin 1 receptor. But the one the beta neurokinin type 1 is the major receptor on the emetic center. Some textbooks they call the emetic center as a vomiting center. So I will use the interchangeable for these 2 terms. And neurokinin receptor, they have a signal they call substance P. The substance P will release from the chemoreceptor trigger zone, and once they have the signal from the chemical, they send the substance P, and substance P gonna bind to the neurokinin receptor. And once the receptor on the emetic center is binding and activated, gonna cause the action of vomiting. That is the chemical part. There's a chemical response from that. But they also have the second part is the local irritant. The local irritant, it can be the xenobiotic that have like the extreme pH property of bacteria or the virus infection. They're gonna scratch to the GI tract, gonna send the signal to the GI tract by the receptor serotonin type 3. and serotonin that activated gonna send the signal to the vagus nerve or the sympathetic nerve to the upper part, which include the chemoreceptor trigger zone or urinary tract nucleus, and both of them gonna send a signal to the vomiting center. These are the second signal that cause vomiting. It is the peripheral local irritant. It's a physical irritant to the vomiting center. And the local irritant, there can be not just only the vagus nerve, it can be the glossopharyngeal nerve or trigeminal nerve that stimulate or activate by the filing or the gagging. Once you use the finger to stimulate your larynx or your neck, yeah, you can cause a vomiting, right? Yeah, that is a pathway of that. And the third signal is from the inner ear. It's like a motion, for example, like a motion signal from the C6, from the car seat, or like an inner ear. They're gonna have like a disturbance, and that's gonna stimulate to increase, or they have the release of the histamine, or the stimulate to the muscarinic receptor, gonna send to the cerebellum, and cerebellum gonna send a signal to the vomiting center, and that causes vomiting. That is the third signal from the inner ear or from the balance of the body system. And the last part, which is the sensory input, is not commonly in dogs or in animals. It's commonly found in human. Like we found some like there's extremely experienced from like smell very bad or like the fear of something, and that gonna from the cerebellum or the cerebrum from the sensory nerve gonna to the higher center and send the signal to the emitting center, and it causes vomiting. And this slide is just summarize I say what's going on and how the vomiting center is happen. The thing you have to know that the receptor of the chemoreceptor zone, chemoreceptor trigger zone, is important that the pharmacological management gonna do to cause a vomiting or stop vomiting, and also the emitting center too. But the drug that have the effect on the emitting center gonna be more effective than the one on the chemoreceptor trigger zone. But the emitting center is protected by blood-brain barrier. So the drug that affect to the vomiting center, they need to cross the blood-brain barrier that can cause an action for that. Any question before I go further? Yes, ma'am.
Can we have a break?
Huh? Oh, yes, sure. Yeah.